Carbon mixer, reducing CO2 emissions from a mixed-use building development. Let's start by opening a new project. You'll see there are some default energy supply systems already present. We're now going to add some demands in the form of buildings. So let's start off by searching for some domestic buildings. We'll look for apartments in the database, and we'll go with some 2006 standard apartments. These are benchmarks, and so the energy demands are per square metre. So we'll specify 1,000 square metres, which equates to about 20 apartments. And here we can see we've got some energy demands. We'll just expand that graph. The heating is there mostly in the winter. We've also got in purple hot water and electrical demands in yellow. The demands are met by hot heating from the gas boiler and electricity from the grid. So now let's add some more buildings to our development. We're going to search for some offices and go with some prestige air-conditioned office designs. Again, we'll go for 1,000 square metres for simplicity. As we apply that, you can see the demand jumped up. We'll now add another building, and we'll search for some retail units in the database and go with a supermarket. Again, we'll add 1,000 square metres. As we apply this, you see the graph has gone off the scale. We need to rescale it. If we look at the breakdown of this, expand that graph, you can see that the supermarket demands are mostly in the form of energy for the chiller cabinets in blue there. And there are the demands for the offices and for the buildings, which are much smaller, and the supplies are shown above the line there. So we'll now look at comparisons. Here we can see the CO2 emissions and the capital costs for this scenario, but we can now generate a new scenario which will go alongside. So let's add a scenario. We'll call it improved buildings. Initially it's identical to our starting case. We can see the details down there at the bottom in the Explorer, but we can now modify things. So let's change these offices from the air-conditioned luxury ones to naturally ventilated open plan and see if that design reduces our energy demand. And sure enough, we can see it has, and there is a corresponding reduction in carbon emissions of 20%. We'll now add another scenario, and we'll now start looking at the effect of renewable energy. First of all, let's consider using biomass boilers instead of gas boilers to supply the heating. Actually, if we apply this, we will end up with two boilers, both a biomass boiler and a gas boiler. It's made no difference at the moment because the gas boiler has got the higher priority. We've changed the priority there, so the biomass boiler is doing all the work now. But let's change it so that the biomass boiler only does 70% and the gas boiler picks up the remainder, which is quite a realistic case. So that's shown a reduction relative to the base case. But now let's change the way we have our baselines set out so that it's now shown relative to the improved buildings. So a 10% reduction on our improved building design with the biomass boilers. We can now consider some other scenarios, other ways of getting that 10% reduction. So here's a new scenario. We'll look at how many photovoltaic panels would we require to get the same reduction. There's our new scenario. Initially it's the same as the improved buildings, but we'll add some photovoltaic panels. We'll try about 70 square metres and see what that does. That's given us a negligible 1%, so it's more like 700 square metres is required to get the 10% there, as you can see. Next scenario, we'll look at wind turbines, only applicable if you've got wind on your site, obviously, but they could help with our capital costs there. So the largest wind turbine we've got in the database at present is 9 metre diameter, and assuming 5.5 square metres of wind. Two of those is giving us an 11% reduction, so that's almost the same, and our capital costs are quite reasonable for that, but it does assume good wind, which is not often the case. So we've got three ways of showing a 10% reduction. Which would we go with? Well, if we look at the annual reductions, because we have reductions in all these cases, as you can see, that implies that we will get a payback. The wind turbine has shown the best payback, then the biomass boiler, then the photovoltaic panels.